The audio you're about to hear was recorded in Anchor.
From ScienceSortOf.com, you're listening to Science Sort of.
Hello and welcome to Science Sort of. This is episode 282. I'm your host, Ryan Haupt, and our theme this week is Anchors Away Part 2. That's right, we're featuring the second batch of short segments I did for the podcast startup Anchor last year. And we got some good ones coming down the pike at you this episode. I got a really cool one about the magnificent frigatebird, which is a great bird if you like birds. I talk about the number pi a little bit. I talk about that new continent that they found over in Oceania. So lots of really cool stuff. Hope you guys dig it. I'm going to string them all together in one long show, which means that all that remains for me to do in this intro segment is tell you what I'm drinking. And I am drinking a beer called the Fiddler's Dream Unfiltered American IPA from Newgrass Brewing, which I believe is from North Carolina, because that was where I was when I got this. So let's give it a taste. Ooh, that's nice. I've been on a bit of a tear about my distaste for the New England style IPA, which tends to be an unfiltered, very cloudy kind of IPA, and I tend to think that they don't have the same crispness and cleanliness, clean taste that I prefer in my more West Coast or Mountain West IPAs, but this one does a nice job and still has a lot of strong flavors while maintaining that rich New England haze and mouthfeel. So give it a try if you like it. Plus, a really pretty can. And if it wasn't this episode, it would probably inspire an easy song because it's got fiddle right there in the name, but we're not going to roll out with that this week because we're going to use something else, which you're going to hear in just a second, and I will see you guys on the other side for some PaleoPOWs. Welcome to Organized Curiosity, the Anchor science station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for the segment BioBIOS. Today's BioBio is for the magnificent frigatebird, Fregata magnificens. I freaking love frigatebirds, y'all. You don't even know what you're in for. Magnificent frigatebirds are found during their breeding season throughout the Caribbean and the tropical waters of the Pacific and Atlantic coasts. Outside of breeding time, they'll head north or south as far as Central California and North Carolina to northern Peru and northern Argentina. I first encountered them on the Pacific coast of Costa Rica and was immediately smitten, as I hope you will be too. The silhouette of a frigatebird in the sky is unmistakable. They have these crazy long wings and a forked tail. Charles Darwin once described them as the condor of the ocean. Their really high wing area to body size ratio means they make flying look really, really easy. They effortlessly soar on thermals, which are columns of hot air used to gain altitude without flapping for it, up to 2,500 meters, and are incredibly graceful in their aerial maneuvers. They will literally stay airborne for days, even sleeping while flying. Let that sink in. It's flying while sleeping. Oh yeah, and by the way, their feathers aren't waterproof, so if they get too wet while flying over the ocean, they die. That's just too hardcore. But birds still gotta eat, so they'll fly super close to the water, sometimes dipping in for a moment to snag fish, squid, jellyfish, and scraps discarded by boats. As you can probably imagine, flying fish, another personal favorite of mine, are an obvious target. Frigatebirds will also harass other birds carrying food, trying to get them to drop their food to be snatched midair by the opportunistic frigatebird. Additionally, certain oceanic hunters like tuna will drive their prey to the surface, so frigatebirds will follow schools of tuna, knowing that the tuna's prey will leap out of the water, thus becoming their prey. Nature is the best, unless you're the fish being hunted, of course. When not flying, they'll perch in trees, bushes, or on the ground if they have to. They're gregarious or social, and will roost in large groups, sunning themselves spectacularly with their wings spread wide in the warm tropical sun. When featuring an organism that makes noise, I'll try to find that noise and play it. So here's the call of a magnificent frigatebird in Ecuador. Now let's talk about sex. If you're not friends with a biologist, I'll let you in on something. It usually takes less than 10 minutes of talking to a biologist for them to mention sex or poop. You've been warned. For most seabirds, there aren't clear differences between the way males and females look. Not so for the magnificent frigatebird. Males have entirely black feathers with a green gloss on the head and a purple gloss on the underwings and back. On the lower neck, males have what is known as a gular sac, gular meaning throat and sac meaning sac. It's a bare patch of skin that can be inflated to look like a bright red balloon, which drives the females crazy. Females are physically larger than males, have no throat bags, and have a less glossy brownish-black plumage with a white patch on their breast and upper belly. Juveniles look like females except with a totally white head. During courtship between August and October, males gather in groups on the ground, inflate their sacs, and just make a lot of motion and noise to try to get the females to pay attention to them. We've all been there. Once a female picks her favorite gular sac and the male attached to it, they build a nest. The male provides the raw material of twigs and the female assembles it. Then the female lays a single egg, they incubate it together for 53 to 61 days, and a chick is born. The chick hangs out in the nest for 22 weeks. The first 7 to 12 weeks, the dad also hangs around to help out, and then leaves, making mom take care of the chick until it is fledged. After which point, she still helps the thing not die for another 4 to 9 months, which is the longest period of extended parental care of all birds. Meaning the female could only breed every other year. Males breed every year because they peace out on raising the kids earlier enough to get down again right away. Having different breeding cycles for males and females is also unique to frigatebirds and just kind of weird in general. Thanks in part to their large distribution, magnificent frigatebirds are not considered threatened by the ICUN Red List. However, there are still some declines in their habitat due to the introduction of non-native predators, especially in the Caribbean, where it's estimated that 50% of their breeding colonies have been destroyed. Additionally, because we humans like to eat the fish that help bring frigatebird food to the water's surface, there is some risk that as we diminish those fish populations, the frigatebird might also suffer. I often recommend folks check out seafoodwatch.org, which is a website and app from the fabulous Monterey Bay Aquarium to make sure their seafood choices are sustainable. So that'll do for this installment of PaleoPOWs. Thanks for listening. If you have your own species you're excited about or a question about something you've heard here, you could submit it to my station or tell me about it on Twitter @Haupt. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the Anchor Science Station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for the segment News You Probably Cannot Use. Bobcats are back in New Hampshire. I think this is one of those teachable moments in science education because the headline seems tame, but there's actually a lot going on. What types of headlines do you typically see when it comes to conservation stories? So-and-so is declining, habitat loss, pollution, overfishing, death, destruction, extinction. It's always a super bummer. And while I think part of the role of science advocacy is to bum you out so that you know bad things are happening when it's our fault, it's also important to explore the randomly positive stories that crop up occasionally. Bobcat basics. Bobcats, Lynx rufus, are the smallest of the lynx group of cats. But don't worry, it's still an awesome animal. They're about twice as big as a typical house cat and the most abundant wild cat in the United States. I saw one once while mountain biking and it was awesome. As in, it literally filled me with awe. They have a short tail, which appears to be cut or bobbed, from which the animal gets its name. If you look at the range distribution of bobcats, you might notice a hole in the Midwest and New England. The only reason for that hole is white people showing up. We know that in part because the bobcat is a common feature of those regions' Native American mythologies, often in opposition to the coyote representing duality. So there's this big hole where bobcats ought to be, but aren't. That hole includes New Hampshire, but a recent study found an increase in bobcat population in the state, despite a decrease in typical prey items such as rabbits. The study suggests that bobcats may be capable of adapting to different food resources like squirrels and turkeys, which is pretty common in mesopredators or middle-sized carnivores like coyotes and otters and whatever. The state ended bobcat hunting in 1989, but considered bringing it back in response to the population increase. People who have a lick of sense oppose the measure because it's sort of like saying if T-Rex came back, we should hunt a few of them just in case, and I personally think that's dumb. So fortunately the hunt was canceled because it's just a tiny cat that used to live there anyway and ain't doing nobody no harm, so put your gun away. It's a rare moment where conservation seems to happen and we're not even sure why. Shooting at it with guns is probably not the best response. Rather, I'd advocate for careful study and continued stewardship of this unique and beautiful American cat. Thanks for listening to my station. If you have your own science news story you're excited about or a question about something you've heard here, you can submit it to the station or tell me about it on Twitter @Haupt. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the Anchor Science Station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for the segment PaleoPOWs. Today's PaleoPOW is for the stag beetle Lucanus cervus. The common name stag beetle can be used to refer to any beetle in the Lucanidae family, so just remember that I'm referring to the specific species, and yes, that is redundant because they are cognates, found in Europe and the UK. The genus name Lucanus comes from none other than Pliny the Elder, a Roman naturalist who wrote extensively on plants and animals in the 1st century AD in his epic tome Naturalis Historia, simply translated as Natural History. Okay, he actually got the name from a buddy of his, Negitius, another scholar who knew that the beetles were worn as amulets in the region of Lucania in southern Italy. I mostly focus on mammals in my own research. So the first thing I noticed about the species name of this critter is that cervus typically refers to deer, or any member of the family Cervidae, which includes deer, elk, moose, and things like that. So the stag and the cervus in the beetle's name are both references to the massive antler-looking mandibles on the males of the species. Mandibles are just another term for paired insect mouthparts used for seizing, grasping, and cutting food, but also for one other thing that we'll get to in a minute. This is the largest terrestrial insect in Europe, but oddly enough, I could only find overall lengths for the species, not any weights. So if you're in Western Europe, please begin weighing any large beetles you find and report back with the results for science. Males can range from 25 to 75 millimeters. For our American listeners, that's 2.5 to 7.5 centimeters. Just kidding, it's about 3 inches max. Females are between 30 to 45 millimeters. The term for when males and females of a species have dramatic differences is called sexual dimorphism. They like to lay their eggs in rotten logs, especially oaks along riverbanks. They also prefer warm, sandy, light soils. Most of the sightings of this beetle come from gardens, which is what folks in the UK refer to as their yards, even if they're not growing stuff. Yeah, it's weird. I don't get it either. The larvae that hatch from the eggs laid on the rotting oak logs live within their logs for 3 months, but up to 4 years before pupating. And I probably need to do an entire segment on insect development, but for now, just think of it as insect puberty when the larvae becomes an adult. Now we gotta talk about those mandibles, because they are impressive and look pretty scary, but are not actually strong enough to hurt you. The typical response of a stag beetle when approached by something large is to just go completely still. So pull out your phone and take a photo. The main role of an adult stag beetle is to mate. Once they emerge from their rotting log of childhood, the males fly around to look for a mate or a male to fight with their mandibles. Beyond that, not much is known. For such a big bug, we really could use some more research on what they're doing with their lives. The beetle is listed as near threatened, so not within the threatened zone, but not to be ignored either. The long time spent as larvae and the tendency of us humans to clear out piles of rotting logs from our spaces are the main culprits. It's possible there's also some threat due to the collection of beetles for commercial selling, but that's less clear. So maybe if you live in Western Europe and have some rotting logs on your property, just leave them alone. And if you don't have any rotting logs in your yard, maybe toss some oak out there and just let it be. So that'll do for this installment of PaleoPOWs. Thanks for listening, and if you have your own species you're excited about or a question about something you've heard here, just let me know. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the Anchor Science Station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for the segment, Better Know a Root. One way to demystify the world of science is to break down common terms in science and making sure everyone is on the same page. Today we're taking a look at the prefix iso, which is Greek for equal. This term comes up all across the various sciences, but I don't think there are many examples in common English, so I'll just use iso as a way to run through some science examples, and to be clear, these things all mean the same thing no matter what branch of science you're talking about, but when I give an example of a field, I'm just trying to make sure that I'm using a field that's relevant to that term. In chemistry, an isomer is a molecule with the same molecular formula as another molecule but a different chemical structure. So you can think about it, if you've got like a chain of carbons, you might have an oxygen molecule on the fourth carbon, and a different molecule might have the oxygen molecule on the sixth carbon. And so, the chemistry, the chemical formula would be exactly the same, but the way that the molecules put together is a little bit different. In physics, an isotope is an atom with the same number of protons but a different number of neutrons in its nucleus. You're probably most familiar with this when it comes to nuclear power. So when we talk about radioisotopes, isotopes that radioactively decay because the extra neutrons make them unstable. In geology, isostasy is a balanced state of equilibrium, which we see in how the Earth's upper crust floats atop the magma of the mantle. So if you add weight to the crust, so like in the form of a glacier, you actually see the crust push a little bit further down into the magma to make it all balance and make it all fit. In biology, wild card, because ISO is a scientific name for a genus of surf sardines. I did not know about that before doing the research for this segment, which is what makes this fun, because I learn things too. In meteorology, an isobar is a line drawn on a map connecting points of equal pressure. If something is isometric, that means their dimensions are all equal. An isocline is a series of lines all having the same slope, so forth and so on. So now you know that anytime you see a fancy science word with iso tacked onto the front of it, that just means they're trying to express equivalence or equality. And I think we all agree equality is a good thing, right? So that'll do it for this installment of Better Know a Root. Thanks for listening to my station. If you have your own root word that you're excited about or a question about something you've heard here, let me know. You can tell me about it on my station or on Twitter @Haupt. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the Anchor Science Station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for the segment News You Probably Cannot Use. If you're on social media, you may have seen a video that's gone viral of a gaggle of turkeys circling a dead cat. There have been lots of jokes about trying to institute a 10th life or dark magic or stuff like that. So let's counter that by talking about what's actually going on. Turkeys live in groups, and as you might expect, they're always on the lookout for predators. While it might make sense to just run or fly, yes, wild turkeys can actually fly short distances, away at the first sign of danger, another strategy is to let the predator know that you've got a posse and are willing to make being hunted not worth the effort. This is especially effective on predators that are about the same size or maybe even a little bit smaller than the birds themselves. So when these birds saw the dead cat, they probably recognized it as a potential predator, but not necessarily a deceased one. A dominant bird within the group walked up to what it felt like was a safe distance to investigate, and his buddies followed behind. So as the leader started making a circle around the cat, the other birds just stayed in that line. The circle shape was maintained in its consistent size because the birds want to be close enough to see what they're investigating, but far enough away to still feel safe. So it's that balance that defines the circumference of the circle they end up walking in. Alan Krakauer, who studies the behavioral ecology of birds, had this to say. During my studies of wild turkeys, I watched a coyote trot through a group of turkeys. The turkeys gave it some space, but acted alert in a similar manner to this video. In that instance, the coyote kept walking and the turkeys went back to their business. However, in this video, the dead cat predator doesn't get up to leave, and the turkeys appear to be kind of stuck in their pattern of behavior. Maybe they are waiting to see if the cat wakes up. I don't intend for this to be a killjoy segment. I'm glad people are getting excited by seeing odd animal behaviors, and I think we can all enjoy learning about what's actually happening while still making jokes about how silly it all is. So let's keep sharing that clip along with the jokes, but now you're prepared for any follow-up questions from your friends too. Krakauer also suggested the PBS Nature episode, My Life as a Turkey, for those who want to learn more. So that'll do for news you probably cannot use. Thanks for listening, and if you have your own science news story you're excited about, please let me know. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the Anchor Science Station dedicated to cataloging everything in the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for the segment PaleoPOWs. Today's PaleoPOW is for the common mudpuppy, Necturus maculosus, which is a large aquatic salamander found from eastern Canada to northern Georgia, the state, not the country. where they can be found in ponds, lakes, streams, canals, reservoirs, and rivers. They like to hang out on the bottom where they can hide under rocks and logs. They're pretty big, growing up to be 20 to 30 centimeters as an adult, and unlike some amphibians, they live their entire life in the water. The common mudpuppy has a flat, squarish head, small eyes, and these red, feathery external gills on either side of its head. The gills can vary in color, tone, and size depending on the oxygen content of the water. Less oxygen requires larger gills because you have to work that much harder to pull the oxygen out of the water. They have smooth skin that can be red, black, and gray-brown, with scattered blue-black spots on their backs or faint stripes. The underside is gray and may also have spots. The patterns fade as the mudpuppy ages, with the oldest ones appearing completely black. The tail is short and flattened, and their legs are also short and have 4 toes on each foot. The mudpuppy might have been so named for 2 reasons. The first because the external gills might look like a dog's flappy ears. Or, the other reason, because people used to think, wrongly, that this species would make barking noises, which again, it does not. So here's the part of the show where I would play what the animal sounds like, but in this case, it doesn't make any noise, and that was part of the misconception. So here's some silence. That's what it sounds like. You're welcome. The main difference between males and females is that the male has 2 bumps on his cloaca. Now we get to talk about what cloacas are. The cloaca is an all-purpose opening found in birds, reptiles, amphibians, most fish, and even some primitive mammals, from which the reproductive, digestive, and urinary functions all go through. The male's cloacal area swells up during mating season, which is in autumn and winter. But the females store the sperm from mating and don't use it until April through June. The female will then internally fertilize the eggs and deposit 40 to 150 of them on the underside of rocks or logs in shallow, slow-moving water. The eggs are little yellow spheres between 5 to 6.5 millimeters in diameter. The females guard the eggs until they hatch 5 to 9 weeks after being laid. The time difference depends on the water's temperatures, so warmer water helps them develop more quickly, cooler water makes it take longer. By the end of August, the young have dispersed from their birth area to spread out in the surrounding habitat, becoming sexually mature after 4 to 6 years. The common mudpuppy is an opportunistic feeder, using their sense of smell to find and eat aquatic arthropods, annelids, mollusks, small fish, fish eggs, insect larvae, and other salamanders. They're mostly active at night to avoid the predators that eat them, namely the North American river otter Lontra canadensis, as well as water snakes, birds like herons, large fish, and again, other mudpuppies, because if they're eating salamanders, then it's possible they might also get eaten by a salamander. And now for the rare opportunity to bring you some good news. These guys are doing just fine. Stable and widespread population throughout their range. Water pollution is an issue for amphibians in general, so locally polluted waters will lead to a decline of certain populations. They're also caught by people while fishing, and if they're released onto land, that's bad. This is a species that has to live in the water. They're not poisonous, and they're not eating the same fish that people like to catch, so it's best just to put them back in the water from where you caught them. The rule of thumb with amphibians is if the water quality gets bad, they let us know by dying. So it's generally a good thing to keep them around and keep them happy, especially if you're intending to eat the fish that you just caught. So that'll do for this installment of PaleoPOWs. Thanks so much for listening. If you have your own organism you're excited about or a question about something you've heard here, please let me know. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the anchor science station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and let's celebrate International Women's Day with Better Know a Root. Today we're breaking down the root term gyno, which is from the ancient Greek word for woman or wife. I was recently told by an actual Greek person that my pronunciation of Greek isn't perfect, which is not shocking. So here's how the word woman/wife sounds in modern Greek according to Google Translate, since they keep ignoring my request to include ancient Greek as an option.
Γυναίκα.
Generally, I try to pronounce foreign root words in this segment the way I've heard them used amongst scientists speaking American English. Occasionally, I'll know how the Brits say it too, so I'll toss that in for good measure. In science and medicine, when we're talking about humans, the root gyno typically refers to the female reproductive system, but females in general when we're talking about plants and animals. So let's dive into some examples. Gynecology literally means the science of women, but is more commonly used to refer to the medical practice dealing with the health of the female reproductive system and breasts. Gynoid or gynecoid means resembling a woman or feminine, and is sometimes used like the term android, which means man-shaped but is generally thought of as a human-shaped robot, except in this case of a gynoid, the robot is shaped like a woman instead of a man. Monogynous, or one woman, refers to a plant only having one pistil or female reproductive organ. And you can tag on whatever numeric prefix to modify that, such as trigynous, which refers to a plant with 3 pistils. Monogyny is also a term for when one male mates with only one female, and for when a colony of social insects only have one queen. This is distinct from monogamy, which means one marriage, from the Greek root gamos, meaning marriage. Polygyny, or polygyny, or many women, is the practice of having multiple female mates for one male. The opposite is polyandry, which is where one female has many male mates, which is actually practiced in some human cultures. Protogynous, or protogynous, or female first, which is synonymous with progynous, is a term used for organisms, both plants and animals in this case, that possess both male and female reproductive organs. The distinction here is that sometimes when an organism possesses both male and female genitalia, the genitalia develop at the same time. If they don't develop simultaneously, and the female organs develop first, then that organism is considered protogynous. And finally, misogyny, or the hatred of women. Mis can also be translated as bad, but I don't think saying bad women makes any sense and is relevant to the behavior of misogynists, so I think hate is the more appropriate definition here. It's a word that's sadly relevant to our modern society, but that's why I think it's important to celebrate days like International Women's Day. The opposite of misogyny is gynophilia, which usually refers to sex but literally means love of a woman, which seems far preferable to me than misogyny. So that'll do for this installment of Better Know a Root celebrating International Women's Day. If you have a question about something you've heard here or a root you're excited about, please let me know. And remember, until next time, to stay curious out there because there is a lot to learn. Welcome to Organized Curiosity. I'm your host, Ryan Haupt, and let's get into the news that you probably cannot use. Update your globe because geologists have found an 8th continent. Wait, really? I mean, we got like boats and satellites and stuff. Shouldn't we have been able to see it? No? I'm being told we weren't able to see it. Oh, it's underwater. Oh, okay. Yeah, it's kind of a weird place for a continent to be. It's in the Southwest Pacific Ocean and has been named Zealandia, and it includes the islands of New Zealand and New Caledonia. The research arguing for the new continent was done by a joint team from New Zealand, New Caledonia, and Australia, and their argument they're making has a few facets, so let's get into some of the basics first, and then I'll tell you what it is they're arguing. There are 2 types of crusts on Earth, geologically speaking, continental crust and oceanic crust. There are chemical and physical differences between these crusts, which affects how they behave within the plate tectonics framework of everything kind of floating around bumping into each other. Continental crusts are felsic, a term in earth sciences that means they are mostly composed of feldspar and silicate materials, so think rocks like granite. Oceanic crusts are mafic, or mostly composed of magnesium and iron-rich minerals, things like basalt or gabbro. Oceanic crusts are thinner and more dense than the comparatively fat and fluffy continental crust, which is one of the reasons the oceans pool over the oceanic crust. It's always going to be lower elevation than the continental crust. Oceanic crust also doesn't last as long as continental crust because its density forces it to subduct or go beneath any less dense crust it converges with while moving around the globe. Any oceanic crust will subduct beneath continental crust, and when 2 oceanic crusts converge, the older, denser crust will subduct beneath the newer crust that is still condensing. So the oldest oceanic crust on Earth's surface is from the Jurassic, so when the dinosaurs were still running around, whereas the oldest continental crust still at the surface is from right around when the Earth formed and cooled down enough that rocks could be a thing. So what is this team arguing? They're saying that the ocean floor between and around New Zealand and New Caledonia is slightly higher elevation than should be expected for oceanic crust. And they showed this using satellite maps made using the Earth's gravitational field, which revealed that there is this coherent geographical feature where the continent is said to be. The oldest rocks from Zealandia are some Middle Cambrian limestones, so they're more than twice the age of the oldest rocks we would expect from an oceanic crust. Additionally, the rock behaves more like continental crust geophysically, meaning the way sound travels through the rocks acts more like felsic and less like mafic. Remember, the density of a substance is directly related to how fast sound moves through it, so the density difference between oceanic and continental crust should be pretty clear. For large-scale measurements like these, the sound waves are actually generated by earthquakes. One big problem remains. There is no agreed-upon way for designating a new continent. Geographers and geologists differ on the definition of continent in the first place, and unlike naming new stars, there's no method or procedure for officially saying, Zealandia is a thing, update all the globes immediately. So while there is all this evidence about the crustal structure and origins of the area they're calling Zealandia, it's up to the scientific community and public to come up with a consensus about whether or not we care enough to agree with the team, disagree, or give a hearty meh. If you have a strong opinion about Zealandia in any direction, let me know. And that'll do it for the news today. Thanks for listening. If you have a science story you're excited about or questions about something you've heard here, let me know. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity. I'm your host, Ryan Haupt, and let's do a bio. Today's bio is for the African civet, Civettictis civetta, which is the largest member of the African vivarids. I'm really excited to feature a member of the mammalian family Viverridae because most Americans probably have no clue what they are. They're a group of mammals found in southern and Southeast Asia, all over Africa, and even into southern Europe. Common names for species within the family include civets, gennets, linsangs, and the binturong, also known as the bear cat. For some perspective, let's take a larger look at mammalian taxonomy for just a second. The order Carnivora is divided into two groups, Caniniformia and Feliformia, literally dog-shaped carnivorans and cat-shaped carnivorans. Viverridae is within Feliformia, and I usually explain it to folks as sort of like the weasel version of the cat-like animals. In fact, the genus name Civettictis is a contraction of the French civet, meaning civet, and the Greek ictus, meaning weasel. Now on to some specifics about this guy. The African civet is widespread and abundant in sub-Saharan Africa, and even found on the island of Zanzibar, but it isn't found in the southernmost part of the continent. Their habitats include forests, swamps, and open savannas. The African civet has stumpy front legs and large hindquarters, making it look like it's always sort of leaning forward. It reminds me of the posture of a stegosaurus. They have a wide head with a pointy muzzle, small eyes, and small rounded ears. Their face looks a little like a raccoon, but the rest of the body has pale yellow to rusty brown fur with a series of dark brown or black spots or splodges, which I had to look up, and that's apparently the British term for a blotch, that are unique to the individual and help camouflage it. They grow between 67 and 84 centimeters, not including their 34 to 47 centimeter tail, and can weigh between 10 to 20 kilograms. When threatened, the African civet apparently has some really impressive vocalizations, including deep growls and coughs. It can also puff up the hairs along its back to look bigger, kind of like a cat, but with just a mohawk instead of all the hair. Here I'd normally drop in the audio of what those growls and coughs sounds like, but I wasn't able to find any. Like many members of the group, the African civet is a solitary nocturnal species. Also, like most vivarids, they're omnivores, feeding on fruit, millipedes, insects, small mammals, and whatever it can find in the trash. In the southern part of its range, it will also go after snails and crabs. This dietary flexibility is part of what has allowed the African civet to spread so far and wide. Because they're nocturnal, our knowledge of the species' habits are limited, but it appears they have communal bathroom spaces where they use their excretions to mark territory and communicate with nearby individuals. The African civet can even augment the smell of its feces by giving them a quick spray with its anal gland. This secretion is famous enough to have its own name, civetone, which is a traditional ingredient in perfume production. You're probably wondering if it's still used in perfume production, but I didn't look that up because I wanted you to be forced to wonder if you'd sprayed civet anal secretions on yourself at some point. Glands on the male are slightly larger, but the female produces a more pungent smell. Breeding season depends on where the animals live, and offspring become sexually mature in 9 months to a year for males and 1 year for females. Gestation lasts for 2 months and change. Females give birth to 1 to 4 young in a nest they build or find, and the young are nursed for 14 to 16 weeks, but begin eating solid food after about 6 weeks. The average lifespan is 15 to 20 years in the wild, which isn't bad for an animal this size. African civet is currently listed as least concern by the ICUN Red List, but because there is economic value to the animal, it is listed on Appendix 3 of CITES, which is an international treaty regulating the international trading of wildlife. All that really means in the case of a non-endangered species is you need a permit from the appropriate nations that you're trying to trade the animals between. The African civet is also commonly found in markets as bushmeat, and there is some demand for its skin with the pretty patterns as well. There is a synthetic alternative to civetone that's been around for 60 years, but yes, it is still used as a fixative in perfumes. You didn't really think I'd leave you hanging there, did you? And so that'll do for the African civet. If you have a question about something you've heard here, or an organism you'd like to see featured in a PaleoPOWs, let me know. Until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, the Anchor Science Station dedicated to cataloging everything we know about the natural world for your edutainment. I'm your host, Ryan Haupt, and it's time for news you probably cannot use. I was on a plane all day today, and I was delighted to land. Okay, not delighted. I was infuriated when I landed because I heard that Scott Pruitt, chief of the Environmental Protection Agency, or EPA, said that carbon dioxide is not a primary contributor to climate change, that our ability to measure the impact of human activity is not precise enough, and that we need to continue the debate, review, and analysis of the topic. He's wrong on every conceivable level, but rather than just bash the guy as a liar, I'm going to instead assume that he's ignorant and use this opportunity for a brief clarification of one or two of his errors. How do we know that CO2 is a greenhouse gas? It may seem like a basic question, but I'd be willing to bet most people don't know the answer, so let's get into it. First off, think about how greenhouses themselves work. The principle is the same as leaving your car in a parking lot on a hot day. The sun emits light across a spectrum of frequencies and wavelengths, including infrared, which is what we use to keep food warm under a lamp, visible light, which is Roy G. Biv, UV or ultraviolet light, which is what gives you cancer, X-rays, you probably know what those are, and even radio waves, which is how solar flares can mess with communications here on Earth. A portion of this light is able to pass through our atmosphere relatively unabated, same as light can pass through a window. When it reaches the Earth's surface, something changes. Because Earth is solid and much denser, visible and UV light that was easily able to pass through the gases of our atmosphere suddenly collide with the much denser matter that makes up solid Earth. This imparts energy to those atoms and causes the temperature of those atoms to rise, same as feeling warmth of the sun on your skin. To return to equilibrium, these atoms then release a lower energy infrared light, which has a longer wavelength. The length of the wave is directly proportional to how likely a photon of light is to bump into other atoms as it zips around. So in the example of a greenhouse, the light coming from the sun can easily pass through the glass of a greenhouse, but the infrared light that's released back after that light hits the ground can't get back through the greenhouse glass, therefore can't get out. The glass that was easy to pass through as a short wavelength is now a much bigger barrier at a longer wavelength. Now replace the glass walls of a greenhouse with our atmosphere. Gases in our atmosphere interact with light in different ways due to their chemical formula and structure. We know for a fact that much like the glass in a greenhouse, carbon dioxide, or CO2, is very good at letting light from the sun pass through it on its way to Earth, and also very good at stopping that light from escaping back out into space, thus acting analogously to the greenhouse glass. How do we know that the amount of carbon dioxide in our atmosphere is increasing? Because no matter what the head of the EPA says, we can actually measure, and have been doing so for a long time, to a pretty good precision what the atmospheric CO2 is doing. In addition, there are a number of indirect and direct proxies that can measure or infer what the carbon dioxide content of the atmosphere was in the past before human activity. One of those methods is testing bubbles trapped inside glaciers, which is just so cool and pretty freaking precise. You've probably also seen someone saying at some point that water vapor and methane are also greenhouse gases. And that's true. Here's the difference that's often left out, and it's a doozy. It's called residence time. Water vapor moves around the atmosphere a lot because Earth, for now at least, exists at a temperature where water exists as a vapor, liquid, and ice. Methane isn't very stable, so while it's a potent greenhouse gas, and we would do well to limit its emission, it only stays in the atmosphere for a few decades. That might sound like a long time, but climate, not weather, is a very long-term, large-scale phenomenon, so a few decades is actually kind of a blip. CO2, on the other hand, will persist in the atmosphere for thousands of years, and is only permanently removed from the Earth's carbon cycle via the process of sequestration, which is a term you may have heard, so let's talk about it for a second. Sequestration means binding up the CO2 in a stable mineral and putting it somewhere where it can't be used in a way that releases it back into the active carbon cycle. So if you make a Tums, which is a calcium carbonate, so it's got carbon and oxygen, so a Tums tablet can be made with CO2, and as long as you never put that Tums in your stomach acid, it'll stay a stable Tums for a while. There are a few ways this can happen besides Tums. One of the most effective ones is the silicate weathering cycle, so literally taking a mountain and letting it erode back down to a molehill, which, as you might guess, takes quite a long time. So while I hate to stand on a soapbox tilting at windmills to mix a metaphor, I believe reasonable people in possession of facts can have different interpretations and priorities when it comes to what we should do about those facts. But the facts remain the facts. So let's at least start there and then get into what we do next as a political and economic discussion I'm not qualified to have. So that's the news today. Sorry, it's kind of a bummer and a bit preachy, but hopefully you learned something about how carbon dioxide works in our atmosphere, and so you can rebut any claims that come up that we're not quite sure what's going on. Thanks for listening. Feel free to let me know if you have a science news story you're excited about or a question about something you've heard here. And until next time, stay curious out there. There's a lot to learn. Welcome to Organized Curiosity, and strap in because we're doing our first two-parter Q&A. I'm your host, Ryan Haupt. Let's get into it. So this Q&A is about how to read scientific literature. So how do you read the actual scientific papers that are being published by the scientists, not just the news releases and press articles that come out after the fact? More and more research these days is being published as open access, which means that anyone can access the full text and data of the study. If you live in the US, this is a good thing because a lot of basic science in the US is supported by the National Science Foundation, or NSF. So if you're a taxpayer, you paid for the research, and more researchers and journals are realizing you might feel entitled to see the results. And they're right. You are entitled to see them. I think it's a great trend in theory. But in practice, learning to read scientific literature is a skill we as scientists have to be taught how to do in our early days as undergrads and grad students. And even then, you're learning how to read the literature and interpret the figures specific to your discipline. If you handed me a paper from even a very closely related field, say like molecular biology or something, I would be nearly as lost as any member of the general public. That being said, I don't want people to be intimidated by the prospect of reading actual science articles when they're available and paid for by all our taxes. So I figured I'd run through a few commonalities found across the majority of scientific disciplines and the literature they publish. The title. Titles are actually one of the more subjective aspects of scientific writing. Within some fields, it's considered acceptable to have a joke or pun in your title, whereas in other fields, it's not so much. And even if your field is accepting of a joke, it's still up to the preferred style of the authors that determines if any cleverness is used instead of just saying what the paper's about. For example, a paper I refer to a lot in my own work is called Teeth of the Toothless, because it's about a group of animals that were scientifically termed edentates, or without teeth, even though most of the species in the group have teeth. A paper I've written about a very similar subject was titled Dental Microtexture as a Proxy for Diet in Xenarthrans. So if the title makes no sense, that's probably because it's written in the most technically dense way possible to get the point across to those in the same field. The authors. Most papers these days will be multi-authored. Authorship is typically granted to those who have had an active role in one, several, or all of the following: the design and implementation of the study, the analysis of the data, and the writing of the paper. First author is usually the person who did the most work, with the amount of work descending with each author. In some fields, it's appropriate for graduate students to include their advisor or whoever runs their lab as the last author, especially if they provided funding for the work, but that varies from discipline to discipline. Large-scale studies with many authors have been known to just list authors alphabetically. The affiliations will say where each of the authors were working at the time of publication, and one author should have an asterisk by their name, marking them as the corresponding author or correspondent, including their email address, so you could actually write them if you have questions about the work you're about to read. I would be thrilled if someone who wasn't a scientist just emailed me to let me know they'd read my work and had a question. I'm being sincere here. That would be wild. I don't know that that's ever happened to anyone I know personally. The abstract. The abstract is a paragraph that summarizes the main findings of the paper. It should outline the problem or question of the study, the method for testing it, a summary of the results, and what those results mean for the field at large. It should walk you through all the main story beats for the study you're about to read. So with that, you're ready to start reading some scientific literature. I'll be back in just a moment for part 2, outlining the rest of a typical paper. My previous segment walked you through getting to the first sentence of a scientific study. So here's what happens next. The introduction. Introductions should lay out the current status of the science that's about to be tested. Historical context, lots of references to previous work, probably not a lot of figures. Ideally, the introduction should also convince the reader that there is a problem or question with what we think we know about the topic in such a way as to justify the work that was done by the research you're about to read. Materials and methods. These sections are the easiest to write and the worst to read. It's essentially the recipe for how you did the work that you did. In many cases, the scientists reading your work are your colleagues and associates and already understand the method, making this section redundant to them. But, and it's a big but, one fundamental idea in science is the notion of replication, that anyone should be able to read this section, do what you did, and get the same result. So it is essential that this section be clear and unambiguous. As anyone who's tried to follow a recipe in a poorly written cookbook, this doesn't always turn out to be true, which is something science as a whole is struggling with right now, but that's a topic for another segment. Because these sections have the potential to break the flow of the story you're reading, some journals are moving them to the end of the paper for those in the field who really want to examine how the research was done and maybe replicate it themselves, but understanding that it's not relevant to most of the readers. Results. This section is the one usually dominated by tables, figures, and statistics. This section also tends to be very discipline specific. The way I report a certain result or build a certain figure is because that's how other people in my field do it or have historically done it, or how my advisor did it, so it makes sense to me because that's how I first learned it. And this can obviously help or hinder a lay reader, whereas I know senior scientists who just go straight to the figures of a given study because they're versed enough in the material that they can just look at the figure and get the info that they need for the entire study. Don't be intimidated by this section. It's the section where scientists find the story that they're telling, but the more narrative part where they explain what that means comes next. Discussion. The final section. This is where it all comes together. The data from the results are interpreted for its larger meaning. The question or problem from the intro is either answered or it isn't, and the future implications for the paper are laid out. This is where the authors have a chance to sell you on what they did, convince you of its value, and chart a path for whatever takes this research on to the next step. The sections that come after that are still relevant, but probably not sections you want to read. I'll still tell you what they are just so you aren't surprised by seeing them. First up is the acknowledgements. This is the section for folks, labs, museums, etc. who helped with the work, but not in enough of a way to warrant authorship. It's just a nice way for the authors to say thanks to everyone else who contributed along the way. It's also a chance for them to thank their funding sources, so this is where you would look to see if the research was supported in part by the NSF, which means you paid for it. References, works cited, or bibliography. Scientific literature is peppered with in-text citations. Sometimes these are in the form of the name of the first author and the year, example, Smith et al. 2016, where et al. Just refers to all the other authors besides the first author. Sometimes the citations are just numbers, and either way, they're all pointing here to this section. So if there's a statement made in the introduction or discussion that piqued your interest and it had a citation, this is where you'll find what it was citing. This is also where scholar.google.com can become your best friend. It's a search engine from Google that's specifically tailored to tracking down these resources. Supplemental data and figures. Some papers will have so much to say or are limited by the format of the journal that they'll include some supplements. These might include a deeper explanation of the method, some additional figures, or just all the raw data generated that would take pages and pages of tables to show, so it's best left out of the paper that people are trying to read, but worth attaching to the work in general because the data is where the story comes from. So I hope that helps you understand how scientific papers work and maybe not be so intimidated by the prospect of reading them yourself. These tips won't help you overcome bad uses of jargon or just plain bad writing, but should be enough to get you over any initial hurdles you might encounter. The next time you find yourself reading a science news story and you see the phrase open access, consider going out and finding the primary source and seeing if you can make sense of it too. If you do, let me know. And that'll do for my first two-part segment. Let me know if you guys like the two-part format or not by calling into the station and saying so. And until next time, stay curious out there. There is a lot to learn. If you've looked at a calendar today, you'll have noticed that it's March 14th, and that makes it Ides of March Eve. But that has nothing to do with science, so instead, I'll point out that it's also Pi Day. If you've seen this meme floating around on social media and were immediately confused, here's the logic. If you write your dates like an American, today's numeric date would be 3-14. 3.14 are also the first 3 digits of pi, an important mathematical constant. And while it's more math than science, I've been crunching numbers and running statistics all day, so to me it feels close enough for me to talk about here. Pi is the 16th letter in the Greek alphabet, spelled in English as just pi. Like English, Greek letters have upper and lower cases. The lowercase pi is what you'd use to represent the mathematical constant we're talking about now, and the uppercase is what you'd see on a sorority or fraternity house and has a different mathematical meaning that we're not going to get into right now. They look very similar. 2 vertical lines with a horizontal line on top that extends a bit past the sides of each of the vertical ones. Pi is defined as the ratio of a circle's circumference to its diameter. If it's been a while since you've taken geometry, the circumference is the distance around the edge of the circle, and the diameter is the length of a straight segment drawn across the exact center of a circle. This ratio, or simply dividing the circumference by the diameter for any circle in existence, is the same number. It's a little more than 3, and that number, being constant, gets a name, and that name is pi. To try to make the abstract more visual, imagine a wheel with spokes, and that one spoke is directly perpendicular to the ground. Imagine now that the wheel begins to rotate and that you keep an eye on that one spoke. It will take 3 full rotations plus a little bit more for that spoke to be in the same perpendicular position as when you began, and that's pi. You may have heard that pi is an irrational number. Well, what does that mean? There are a few criteria. First, it has to be a real number. Yes, there are imaginary numbers. The quick and not at all in-depth difference is that real numbers have to have a place that exists on the number line somewhere. An example of an imaginary number is something like the square root of -1, if you can wrap your head around that. The next criteria is that an irrational number cannot be expressed as a ratio of integers. Integers are just whole numbers without any decimal places after them. So things like 1, 2, 4, 8, 16, 32, 64, 128. Whoa, sorry, I started to Fibonacci out there for a second. Anyway, a ratio of integers would be something like 1/4 or 1/4. So that means we have to write irrational numbers using decimal points, which brings up the final criteria and the one that makes pi, in my opinion, so enchanting. No finite number of digits after the decimal point can represent the exact numeric value of pi, and at no point does a repeated pattern emerge like the decimal values for 2/3, which are 0.66666 repeating forever. I think this irrationality is a lot of what makes pi such a romantic concept, and it's a concept humans have been thinking about for a long time. I'll talk a little bit more about the history of humanity's obsession with pi and some of the ways we've attempted to calculate it over the years in a segment that's coming up in just a moment, so stay tuned to Organized Curiosity. Remember to stay curious out there because there is a lot to learn. In my previous segment, I talked a little bit about the definition of pi and exactly what that definition means in terms of pi being related to circles and also an irrational number. Now I want to talk about the history of humanity's efforts to calculate pi and get it out to that infinite decimal point horizon that we will absolutely never reach. So let's get into it. People have been working on a formulation of pi since long before Jesus was born. There are even passages in the Old Testament of the Bible discussing the measurements of cauldrons that in some ways were an early approximation of pi. The earliest written approximations of pi come from ancient Egypt and Babylon, from around 4,000 to 3,500 years ago. They estimated pi as 22/7 or 25/8, and I should remember being taught those approximations in middle school, but they are only approximations because, again, as an irrational number, pi cannot be expressed as the ratio of 2 whole numbers. A later method for estimating pi was developed using polygons of increasing sides. You can probably visualize that a square is closer in shape to a circle than a triangle, and that a pentagon is closer to a circle than a square. You can use the same formula of dividing the length of the edges by the maximum interior distance and get a number that is close to pi. The more sides you add to your shape, the closer that number gets, which brings us to a big breakthrough. Limits. This one might only make sense if you've taken calculus, but here goes. And I won't get into the math too much, so just roll with me for a second. In the 16th and 17th centuries, mathematicians figured out how to calculate the sum of the terms of an infinite sequence of numbers. This technique was actually first figured out in India, but as will come as probably no great shock, more credit is given to the white dudes in Europe who figured it out independently, but a bit later. Again, I'm not going to get into the math of it, but you can think of it as sort of an abstraction of the polygon method, where you keep adding sides to the polygon, but with the addition of some math that allows you to say, as the sequence approaches infinity, the sum approaches some number. In this case, that number is pi. Assigning the Greek letter pi to the numeric value of pi was first done by Welsh mathematician William Jones in 1706. And since the development of computers, there's been this huge spike in the number of digits we've been able to calculate for pi. The current record is around 10 to the 13th digits after the decimal point, which is 10 with 13 zeros, so about 10 trillion digits. There are lots of really cool computer algorithms coders have come up with, and if humanity doesn't go extinct or manages to build robots that can maintain supercomputers, I have a feeling we'll be working to calculate just one more digit until the heat death of the universe. So enjoy a slice of the food type of pie today, and annoy your friends with the random pie factoids you learned here. If you have a favorite irrational number, Greek letter, or other mathematical concept, let me know. Make sure you favorite this station if you want more science content like this every single day, and you can find more of my geeky ramblings on Twitter at Haupt. Check the station description for the spelling of my last name. Until next time, stay curious out there. There's a lot to learn. So I hope you enjoyed some of those segments from my anchor station. If there's any that stood out to you in particular and you thought maybe they would warrant even a little bit more information, let me know. Write in PaleoPOWs@scienceorb.com or call us on our voicemail line 312-PaleoPOWs. It's 312-725-3672. Now, because it's me riding solo today, we are not going to do a patron thesis. But I did want to point out something on the Patreon, and that is that thanks to the patrons, we are now slowly going through the back catalog and getting all of our old episodes transcribed. That was the goal we hit when we started getting $100 a month, and so that is really exciting. It increases our searchability because now the Google bots that scour the internet for all the things to be searched can find every single word that we've said in the episode as we work our way through them. And it's an accessibility thing, so if people are hearing impaired, they can still find the show and enjoy it that way. We are getting transcripts done in the order of download popularity, so if there's an episode you really like and want transcribed, maybe go secretly download it like 100 or probably closer to 1,000 times, and that might make enough of an impact to get it transcribed more quickly. You can see those transcriptions on the website at scienceordof.com, and I would like to thank all the lovely patrons for making that happen. But before we go, I do want to do a PaleoPOW for myself, and I am going to do some iTunes reviews. So we recently had a bit of a dust up where we got a lower than 5-star reviews, and it knocked us from a full 5-star rating on iTunes to a 4.5-star rating. Now, I've done the math, I think, and iTunes doesn't make this super clear. It's a pretty opaque system, but I think it's actually going to take us a pretty good push to get that 5-star back up there if my estimates on how they round these things are correct. So I want to give a special shout out to a few recent reviews that came through and hopefully encourage more people to go write reviews if you haven't. First up, jeffluckclub, 5 stars, says, praise science. I love this show. They do a wonderful job of presenting sciencey topics in a digestible and comical way. I always recommend the show to everyone I know. Also, Charlie has a super sexy voice, so his episodes are my favorite. Jeff, you are correct. Charlie does have a super sexy voice. There is no denying the power of those dulcet tones. We have another one for science, 5 stars, and this is from ND Power. I think that's neodymium power. Anyway, they say, hey, Paleo team, as a marine biogeochemist, I highly recommend this podcast. Fill your free time with scientific, lighthearted discussions of anything and everything. Woo! Go team! Hey, if you're a marine biogeochemist, you might need to come on the show instead of just listening to it. You should write in and tell us what you study. That sounds super cool. Another 5-star review from Willcrimson. Science made understandable. Despite touching on hard topics, the host and guest managed to explain hard science topic that even a non-scientist like me can understand. That's right, man. We are taking on the hard topics for you. Kitty396 says, I enjoy this podcast. Maybe enjoy is not strong enough. I would say I love it, but I do not know if that is strong enough either. I guess I will go with that I want to get my PhD in this podcast. So Kitty, I'm sorry to say that currently we are only offering terminal BSSOs. We're not offering graduate level degrees in science, sort of, but maybe that we can make that a patron level. And with enough donations, we can start our own unaccredited for-profit university. Thanks for the idea. Last up, Steven767 says, great podcast. I recently found this podcast, and I'm so glad I did. I really enjoy the topics that are presented, as well as the dialogue in every episode. I've already learned a great deal of new information from several different fields of research. Great! That is great, and we are super happy to have you on board. So thanks to those folks who wrote reviews on iTunes. If you have time and are willing to do that for us, it is the best way to help keep our beautiful Thomas-designed logo art high in the iTunes store for everyone to see and come check out and be intrigued and be like, what's this? It's a dinosaur skull, but it's got like moose antlers. Maybe it's a great show. And it is a great show, but it's a great show because we have you guys out there listening and promoting and patronizing and doing all the things that make a podcast happen. So thank you so much for listening. Hope you enjoyed my anchorings this time, and I'm not out of them yet, so from time to time, if our recording schedules haven't quite synced up right, I might drop another one of these in the future. So feedback is always appreciated. Let us know how you're doing out there in podcast world, and that'll do for this episode. So because I'm alone, I never quite know what to do. I guess anchors are like boats and nautical themes, so maybe I'll just say come back next time for a whole lot more science, and then I'll do like sort of, but I'll put a boat horn on it, or a ship horn, some kind of horn. Okay, bye.
Visit sciencesortof.com for show notes, links to all the stories we talked about, and ways to interact with the hosts, guests, and other listeners. Science Sort of is brought to you by the Brachiolobe Media Network of podcasts, with audio engineering by Tim Dobbs of the Encyclopedia Brunch podcast. That's all for this week. See you next time on Science Sort of.
That's the end. Doesn't have to be a whole big thing every single time. That's life. That's just sort of how it goes. Sometimes things just sort of end.